Hello all, let's start section 3.5. Your section 3.5 is summary of curve sketching. Summary of curve sketching, it means 3.1, 3.2, 3.3, 3.4. Whatever you learn in chapter 3, all of them comes in one problem. And if you put all those pieces together, finally, you can sketch any curve. It doesn't matter that that's a trigonometric curve, algebraic curve, a function, it doesn't matter. Any type of curve, you can sketch it in this way. In algebra or in trigonometry, you have different methods. But here, you can sketch any curve. But you have to use 3.1, 3.2, 3.3, 3.4. All of them, you can just sketch a curve. Now, let's discuss a little bit. I'll give you the steps. There are 8 or 9 steps that you have to follow to kind of sketch a curve finally. In your book, it shows as a ABC, or a step 1, or a step A, a step B, a step C. A step A. And a step A, what you do, you always look, oh, it's too tiny. Let me take this one maybe. You're looking for the domain of your function. That's your step A. When they give you a function and you start with the function, your first step is to find the domain. I'll do an example later and I'll show you, and I think everyone knows how to find the domain of a function, correct? Step B. In step B, look for the intercepts. It means find your x-intercept and find your y-intercept. To find the x-intercept, you know it's algebra, I shouldn't discuss it, but still I am discussing. To find the x-intercept of a function, you put f of x, or you may name it y, equal to 0. To find the y-intercept, you look for the f of 0. It means you put x equal to 0. Correct? Step C. In step C, look for the symmetry. Remember from algebra, even I discussed it in chapter 1 with the functions, that if a function, f of x, f of negative x, equals to the f of x, correct? If a function is given, you replace x with negative x and you evaluate. If f of negative x becomes equal f of x, we call that function an even function. And when a function is even, its symmetry about y axis, right? And f of negative x, f becomes equal to the negative f of x. In this case, you are dealing with the odd function and its symmetry about x-axis. Of course, we have periodic functions like sine, cosine. If your f of x plus p, a constant, becomes equal to the f of x, we call this one periodic function. For example, y equals sine x, right? It's a periodic because in every 2 pi, it's repeating. The period for the sine is 2 pi, right? Trigonometry. Step B, in step D, look for the asymptotes. Find the vertical asymptote, find the horizontal asymptote. Remember these from chapter 1, if you have the limit of f of x as x approaching to a, from the right, it can become a positive infinity, or limit of f of x as x approaching to a, from the left, it can become a positive infinity or negative infinity, from the right, sorry, or limit of f of x as x approaching to a, from the left, can give you a positive infinity, or limit of f of x as x approaching to a, from the left, can give you a negative infinity. These were the evaluation of a vertical asymptote, correct? Or you can find the limit at infinity, your horizontal asymptote. I'll do it in an example. Anyway, in part D, correct? Always look first for asymptotes. Part E, interval of increase and decrease. Interval of increase or decrease. Remember interval of, for each of them, I had a lecture for you, 3.1 to 3.4. How do you find the interval of increase and decrease? You have to first find f prime x, right? Your critical numbers, right? If f prime x is greater than 0 in an interval, your function is increasing. And if f prime x is less than 0, your function is actually decreasing, right? But first you have to find the critical numbers, correct? And after that, in that interval, check the f prime of x. Part F. These are all the steps. And at the end, you can graph a function. Part F, local max and min. Local maximum and minimum values. To find local max and local minimum values, what you do, remember this, first you have to find f prime of c. Your c was your critical point. First you make it equal to 0, or f prime of c can be DNE, right? It means an asymptote. Now, do the f prime test. Then f prime test. What was the f prime test? An f prime test, you were looking to this. If you are going from positive to negative, you have a max, right? Like this. From increasing to decreasing, here you have a max point. And if you are going from negative to positive, you have a min. Like this, right? Here you have a min. Part G. Interval of concavity. Concavity. To find concavity, and also with concavity, you can find inflection point also, right? Inflection points or points of inflection. What we do, we compute second derivative, double prime of x, f double prime of x, and use concavity test. All of them is in your lecture. correct? If double prime of x is greater than 0, you know you are concave up. And if double prime of x is less than 0, you are concave down. Correct? Inflection point, when you are changing from positive to negative, when you do this, from concave up to concave down, there is a number there that you call it inflection point, right? And you can calculate that inflection point. And part H, last step, graph. Now, I will do an example for you, only one example, and show you all the steps in this example, how I apply all my steps, and finally, I can sketch a curve. Example number 1. Y equals, or f of x equals 2x squared over x squared minus 1. This function is given to you. They are asking you to sketch the graph. My step A was domain. I want to find the domain of this function. This function, you see, it's a rational function. I have to first set the denominator equal to 0, right? What I do, I set x squared minus 1 equal to 0. I will factor it nicely. X plus 1 times x minus 1 equal to 0. From here, x equal negative 1. And here x equal 1. These are the vertical asymptotes actually. And also we call it this one the critical values, or the numbers that I want to show it on the number line, correct? Here, for example, negative 1, here 1, I'll mark 2 points. X cannot take 1 and x cannot take negative 1 because they are the vertical asymptotes. Now you see this number line helps me too much to can write my domain. Then what is the domain of this function? It starts from negative infinity to negative 1, union from negative 1 to 1, union from where? From 1 to infinity. Why you are doing the domain? Actually, right now, even you are in step 1, but you should know, oh, my graph has 3 pieces. Because here I have a vertical asymptote, here I have a vertical asymptote, then I have a piece here, or here maybe, here another piece, and here another piece. This graph has 3 pieces. Even in a step 1, it gives you the information that, hey, don't do a mistake. Your graph has 3 pieces. Correct? Anyway, step 1, find the domain. We found the domain. Step B, or step 2. X-intercept and Y-intercept. X-intercept and Y-intercept. Let's first find the x-intercept. Your function is f of x or y, whatever. I'll write f of x. F of x equals 2x squared over x squared minus 1. All of you, you know, at least you remember this much from algebra, that if you want to find the x-intercept of a function, you have to set f of x equal to what? To 0. It means 2x squared over x squared minus 1 equals 0. Even some professors, they don't write the denominator, which is correct, right? For a rational function, if you want to find the x-intercept, just set the numerator equals 0. Anyway, you are multiplying both sides by x squared minus 1. It means this one goes away. then you can write 2x squared equals 0. It means x equals 0. Then where is my x-intercept? My x-intercept is at 0, 0. When y is 0, x is 0. Y-intercept, you have f of x equals 2x squared, over x squared minus 1. To find the y-intercept, look for the f of 0. It means plug in x0. It gives you 2 times 0 squared over 0 squared minus 1, which gives you over negative 1, which is 0. It means your y-intercept is also 0, 0. We are done with the step 2 or a step B. Step C, symmetry. The function is given f of x equals 2x squared over x squared minus 1. Focus here if you forgot about how to do. Look for the f of negative x. Correct? Find f of negative x. It means wherever that you have in your function x, replace it with negative x. This one will be 2 times negative x squared over negative x squared minus 1. Simplify. Let's do it simplified here. 2 times negative x squared gives you positive x squared. Negative x squared gives you positive x squared minus 1. Wow. Is this the same as your function? Look. This one and this one is the same, right? Then I can say f of negative x equals to the f of x. They are the same. Oh, my condition. When f of negative x is equal f of x, then I know my function is even and its symmetry. It's symmetric about y axis. Correct? I'm done with the step C. Step D. In step D, we are looking for the asymptotes. First, vertical asymptote. I know in many classes, maybe you have friends and other calculus classes, they make this part easy. They want to skip one part, but we don't because we learned everything. We know how to deal with. Look, the function was like this. Y equal to x squared over x squared minus 1. Because you already found that x equal 1 and x equal negative 1 are vertical asymptotes. I'm totally agree with other professors that yes, you already found it in step 1, but actually what does it mean? Why we deal with limits in this part? Because we want to see the behavior of the function around the asymptote. Wow, I give you a sentence. The behavior of the function around each asymptote. Then what does it mean to me in algebra? It means find the limit of 2x squared over x squared minus 1 as x approaching to -1 from the right, find the limit of 2x squared over x squared minus 1 as x approaching to -1 from the left. Also find the limit of 2x squared over x squared minus 1 as x approaching to 1 from the right, and limit of 2x squared over x squared minus 1 as x approaching to 1 from the left. Why you want to do this? I told you, I saw before in many classes of Calculus 1, they don't want to do this part. Oh, vertical asymptote at x equal 1, x equal -1. But look at your book. We are covering this. The reason why, because we want to know what is the behavior of the function around the asymptotes. And I will show a little bit of graph here for you, correct? Now, let's find these. Limit of 2x squared over x squared minus 1 as x approaching to -1 from the right, right? For example, plug in here -0.5. You see here that when your function goes to -infinity, and when you do this limit, actually all of you learn how to deal with. You can deal with the table. You see this one goes to positive infinity. Around 1, here your function goes to infinity here, and here your function goes to -infinity. Let me show you a little bit of graph. I shouldn't do the graph immediately here for you. I should wait for the last step to defend myself from the other classes that they say, no, it's not important. Only I know my vertical asymptotes, why I should do this, correct? That's why I want to do this, to show it for you, why we are doing this, why we take these limits. X, Y, 1 and -1, right? Now look how these limits are helping me to know at least where the graph goes. At least I know. I will not graph, at least I know. When x is approaching to the -1 from the right here, this part, when you are approaching this way, the function goes to where? To the -infinity. It means function goes this way. It means, oh, the curve maybe is something like this. When approaching, you are approaching to -1 to the right, the function goes to infinity. Here, it means you have another part goes like this. When you're approaching to 1 from the right, you see you are going to infinity. Oh, this part goes like this. And when you are approaching to 1 from the left, you see you are going to negative. At least I know where, if I remove these 2 arrows, which is they are extras, now I know kind of where the function goes. That's why you do limit. Correct? Now, horizontal asymptote, we just covered it in the previous lecture. The function is, you take the limit of the function, which is 2x squared over x squared minus 1 as x approaching to where? Infinity. And we already learned, we divide all terms by the highest exponent of denominator, which gives me limit of 2x squared over x squared over x squared over x squared minus 1 over x squared as x approaching to infinity. Let's simplify. Limit here gives you 2 over 1 minus 1 over x squared as x approaching to infinity. This part becomes 0, right? Because you are approaching to infinity. Then you end up, your answer is 2, right? Your limit becomes 2. It means y equal 2 is your horizontal asymptote. If I graph it here, for example, this is 1, this is 2. At y equal 2, you have this horizontal asymptote like this. Oh, at least now I know this part of the graph. This part of the graph will be something like this. And I know now this part of the graph. Just I want to know where I'm turning here. You see how, when you're dealing with calculus, how calculus helps you to do the graph, right? More complicated than algebra, definitely. But remember one thing, in calculus, you are able to graph any curve, not just functions, right? Next step, which is step I am, step E. Yeah, A, B, C, D, E. We can practice our ABC here, right? Step E, we are looking for interval of increase and decrease. Interval of increase and decrease. Also, you can talk here about max and min, correct? Same thing. Okay, the function is f of x equals 2x squared over x squared minus 1. Let's find first f prime x. Don't start shouting. I know f prime x, here you have to do the quotient rule, right? Let's do the quotient rule. The derivative of denominator or your g, which is x squared minus 1, times the derivative of numerator, which is 4x, minus numerator, which is 2x squared, times the derivative of denominator, which is 2x. Correct? Over denominator squared. X squared minus 1 all squared. Then f prime x equals, let's simplify the top. 4x times x squared gives you 4x cubed. Minus 4x, distribute 4x here, right? Minus 4x here, minus 4x cubed over x squared minus 1 all squared. Negative 4x cubed, positive 4x cubed cancels out. Then f prime x equals negative 4x over x squared minus 1 all squared. That's your f prime x. Correct? I already know my critical points, which was my vertical asymptote, negative 1 and 1. Now I have to do a sign chart or a sign table. During the lecture, I used a table for you. Here I'm using a number line, which is the same thing. Pick up a value from this region, from negative infinity to negative 1. For example, let me change the color. For example, let's pick negative 2 and plug in negative 2 to where? To our f prime. Then f prime of negative 2 equals negative 4 times negative 2 over negative 2 squared minus 1 all squared. I don't care about numbers. I told you, we are analyzing the sign. Negative times negative gives me positive. Denominator, whatever inside the bracket is, when you square it, it gives you always positive, correct? It means in this region, the sign is positive. Sign positive, what does it mean? When f prime x, when your f prime x is greater than 0, means positive, the function is doing what? Increasing. Then here your function is increasing, you see? If you say no, let me go back to the graph and show you. Here, from negative infinity to -1, you see your function is increasing, going up like this. Now, pick up another test point between -1 and maybe another critical point 0, because at if you plug in 0, everything becomes 0. Let's put it between 0 and -1. I will not show, to save some time, I will not show the operation for you, but if you plug in that number, you will see, again, you end up with positive sign. And if you plug in a number between 0 and 1, here you get a negative, and here also you get a negative. It means what? It means here your function is increasing, here your function is increasing, here your function is decreasing, and here your function is decreasing. Then, interval of increase. The interval of increase is from -1 to, from negative infinity to -1, and also from -1 to 0, that's the interval of increase. Interval of decrease will be from 0 to 1, and from 1 to infinity, that's the interval of decrease. Okay, part F. If I ask you where I have a max or min, right? A, B, C, D, E, F. Part F. Let me change the color. Part F. I'm looking for max and min, local max or local min, correct? Just copy your sign chart again here and talk about local max and min. -1, 0, 1. Here it was positive, right? Let me zoom in a little bit. Here you have positive, function is increasing. From -1 to 0, increasing. From 0 to 1, decreasing. You see the arrows? From 1 to infinity, again decreasing. The only sign change, here was positive, here negative. When you go from positive to negative, I gave you this definition before. When you go from positive, when you change from positive to negative, you have what? A maximum point or a local max. Correct? Or G. Or G, F double prime or interval of concavity. Concavity. Okay, f prime x, we already found f prime x equals -4x over, I think it was x squared minus 1 all squared. Now we are looking for the f double prime of x, the second derivative of the function. F double prime of x, again quotient rule. Denominator, which is x squared minus 1 all squared, times the derivative of top, which is -4, minus your numerator, -4x, your function f, times the derivative of denominator. Focus here. You have x squared minus 1 all squared. You have to use a chain rule, right? The derivative of outside, which is 2. the derivative of outside of the function, times the derivative of inside, which is 2x. All over denominator square. It means x squared minus 1 to the power of 2 to the power of 2, which gives you to the power of 4. Correct? Let's simplify. Some people, they distribute. No, focus a little bit, please. Don't distribute. Here you see between this term and this term, x squared minus 1 is common, right? Let's take that one common. Let's simplify it easily. If double prime of x equals, I'll take x squared minus 1 as a common, or I'll factor it out. What left inside here, negative 4 times x squared minus 1, one of them, correct? Negative times negative gives you positive. This one, you took it already as a common. 2x times 2 gives you 4x. 4x times 4x gives you 16x squared over x squared minus 1 to the power of 4. Here, you can cancel this parentheses with one of these. You end up with 3. Then f double prime of x equals, distribute here, it gives you negative 4x squared plus 4 plus 16x squared over x squared minus 1 all to the power of 3. Simplify. F double prime of x equals 16x squared minus 4x squared gives you 12x squared plus 4 over x squared minus 1 all cube. Now again, my number line or a table, correct? Negative 1, 0, 1. Interval of concavity. Pick up a number from this region, for example, negative 2, right? Plug it here in this function, and I'm sure you end up with a positive sign. Pick up a number between these regions, negative 1 and 0, for example, negative 0.5, you will end up with a negative sign. Here also negative, and here also positive. Okay, now what does it mean? Wherever you have positive, concave up. Where here, concave down. Negative, concave down. Positive, concave up. Why? Why I know this? Because f double prime of x is greater than 0, I have concave up. When f double prime of x is less than 0, I have concave down. And here f double prime of x is greater than 0, I have concave up. Correct? If you add all this information, I'm a bit lazy, I don't want to do again the graph, you will see you will end up with this graph. Why I'm turning here? Because that was my y-intercept and x-intercept. That's the shape of the graph, and that's your step H, that you put all the information together and you can sketch any curve. Now, it's an online class. During the test, you will not do a graph for me, but every single part of this problem, step 1 to 8 or a step A to H, 2 steps can be one problem for you. For example, find the interval of concavity. Find the interval of increase and decrease. Find inflection point, correct? Find the vertical and horizontal asymptote. They come as a separate questions for you. If it was a face-to-face class, of course, I would tell you, okay, graph some functions for me. We are done with 5.5. We escape 5.6 because we are not using graphic calculator. Your 5.6 is how to use graphic calculator to graph a function. Because we are not using it, we skip 5.6. And see you all in section 5.7, and I'll stop the lecture now.